Starting out here in chapter 6, we're kind of going to go back to a little bit of our basics of graphing. You know how we graph any kind of time we want to graph a line, all we have to do is get that equation in y equals form or slope-intercept form, and then we can just graph the y-intercept and the slope, and we call it done. So what we're going to do is take that whole concept of graphing line, but what we're going to be doing this time is graphing a linear inequality. And the difference between a line and inequality, there's just a few changes, not too much, but just a little. But the big thing when you're looking at the equation is that you don't have equal signs anymore. Instead, in your equation, you have these like less than or greater thans, or you have less than or equal to or greater than or equal to's. So you have different symbols in there. And those symbols right there is going to be what's kind of a little bit different. You know, if we had just had one variable and I asked you guys to solve, 2x minus 3 equals 4, the first thing we would do is, move that 3 over and then divide by 2, so you get x to be, what, 7/2? But what if I go around and I start changing it to, instead 2x minus 3 is greater than 4. So this time I move my 3 over, I divide by 2, and I get x is greater than 7/2. So in a regular form, when I have an equal sign, I get one answer. It's just 7/2 and that's it. However, when I start throwing in inequalities, all of a sudden I have almost an infinite number of answers because it's all the numbers, and we sometimes graph this, remember, on the number line? And what we're looking at is all the numbers larger than 7/2. And technically, anything that's larger than 7/2 or 3.5 is a solution to this inequality. And so that's what we're going to be kind of doing is we're taking it from a one dimension where we have one variable into two dimensions where we have two variables. And the way to kind of graph your answer or graph your solution is we're going to be shading the graph. Okay? Well, looking here at step 1, just normal like before, all you want to do is make sure that your inequality is in slope-intercept form. So just solve it for y. And then as with any inequality, if you ever have to divide by a negative number, you've got to make sure you reverse the inequality sign. So change it from less than to greater than, that kind of thing. Step number 2 is also really one of the key differences here when you're graphing an inequality, is all about how to graph the line itself, the boundary line we call it. Okay? If your inequality has just strictly less than or strictly greater than, then what we're going to be doing is graphing a dashed line. And if it's less than or equal to or greater than or equal to, we're going to do our typical solid line. And then last but not least, of course, like before, is on this number line where we kind of had a shade over our solutions, we got a shade on this graph. And how some ways you can determine is if it says y greater than or y greater than or equal to, we're going to shade above the y-intercept. So the half of the graph that's covering above the y-intercept. And if it's y is less than or y is less than or equal to, we're going to shade the part of the graph that's below the y-intercept. Okay? So I bet a lot of you guys have done this before, but let's go back into it. Let's refresh our brains just for a second, and let's try example number 1. So as we look here at example 1, let's kind of go through the steps. So step 1, what we want to do is we want to solve it for y, get y by itself. So let's move these x's over. We get negative y is less than or equal to now a negative 2x plus 4. And let's divide everything through by that negative 1. And like I said, right there, we're dividing by negative 1. So anytime you multiply or divide by a negative number, we have to reverse that inequality symbol. So now it goes from less than or equal to greater than or equal to, and then a 2x minus 4. Okay, so this is really the line that we're looking at to graph, because we have a y-intercept and we have a slope and everything's ready to go. Now point number 2, we wanted to go back and we wanted to analyze what's sitting right here, our inequality symbol. Well, because it says greater than or equal to, we're going to still keep drawing a solid line. That's always a great thing to check for, because our habit is always draw the dots, connect the dots with a solid line, call it done. But now we got to slow down for 2 seconds, because if that just said greater than, it would have to have been a dashed line. So that's definitely something to check out for. Okay, third step. Let's graph this, and we have to shade. Figure out how we're going to be shading that. Okay, we have a y-intercept down here at negative 4. And we have our slope is positive. So with a positive slope, that's telling me that this graph should definitely be increasing as I go from left to right. So I'm going up 2, right 1, and up 2, right 1. Okay, if we connect this with a solid line, then we're done with step 2. And now all we have to do left is shade. Well, this says y is greater than 2x minus 4. So I want all the y values that are larger than the line. Think of the 2x minus 4 as being the line, so I want the y values that are greater than the line. So if we look here on this, let's kind of come from here. Here's the line that's kind of cutting right through here at negative 4. So what's larger than negative 4? Is negative 5 and negative 6 larger, or is negative 3, negative 2, negative 1, and 0 larger? Well, obviously all these positives are actually larger than the smaller negatives. So what I want to do is make sure I'm shading over the part of the graph that covers those larger y values. And there you go. And if you wanted to, I know a lot of you guys have learned this through testing, just pick any point that's in this shaded area. Like let's say I want to pick 0, 0. Okay. What I'm going to do is go back up into the inequality. I can just do the original one and plug it in and make sure I get a true answer. So is 2 times 0 minus 0 less than or equal to 4? Well, 0 minus 0 is 0, and that's less than or equal to 4, so yes, it checks out. And that should happen no matter what point. If I picked the point 1, 2 and I plugged it in, I should get a true statement. If I picked, let's say, 1, 2, negative 3, negative 1, and I plug that in, I should get a true. Anytime I pick anything that's in the shaded region and I plug it back into my original inequality, I should always get a true statement. And that's a good check if you wanted to. Okay, so let's go on to example number 2. We want to graph the line x plus y is greater than 0. So get y by itself. Let's move this x over, and it says y is greater than negative x. Okay, well, right there, and if you wanted to, we don't really have a y-intercept. There's not a number back here, but if we wanted to, we can just say plus 0. So you can always add 0 and it hasn't changed anything. Point number 2 was to say, look at that inequality. It's just greater than, so we want to draw a dashed line. Okay. Well, let's put all this information together. We have a y-intercept at 0. And the slope is always that number, that coefficient on the x variable. Well, in this case, the coefficient on that x is a negative 1. And it's a negative slope, so I should be decreasing from left to right. So it's going to be like down 1, right 1, or up and left. I've got to make sure I'm decreasing along my line. Okay. And like we said, it's got to be dashed, because my inequality is just a greater than or just a less than. Okay, so let's finish this up. Let's figure out what side we want to graph on, or what side we want to shade on. It says I want my y values to be larger than the line. Okay, so here's the line kind of coming through here. Kind of getting here. I usually put my pointer on the y-intercept. What's larger than 0? Is 1, 2, 3 larger, or negative 1, negative 2, negative 3? Obviously the 1, 2, 3. So I want to make sure I'm shading over that positive, the larger side. And like what we did just in example 1, if you want to go through and test, let's test. How about that point right there? It's obviously in the shaded region, 0.11. Let's go to the original inequality. Is 1 plus 1 greater than 0? Well, last time I checked, it is, so we are good to go. If I wanted to try another one, let's say right there, 3, 0. Well, is 3 plus 0, because is the x value plus the y value still greater than 0? Yep, that one checks off. So we know for a fact that we've got our answer correct. All right, let's go to number 3, example number 3. Just like before, we want to get the y by itself, so let's move this 2 over. We get 3y is less than negative 2. Divide off that coefficient. Well, the coefficient's positive, so I don't have to worry about reversing my inequality symbol. It's just y is going to be less than a negative 2/3. Where's the x variable? How am I going to graph this? Do you guys remember back in when we started talking, when we did lines and everything, that if you're ever graphing a linear equation and it only has one variable in it, you're either doing a vertical or horizontal line. So right here from the start, because there's no x variable, we'll write this little note out, no x variable, so this means it's a horizontal line. Because if your variable, the only variable that's present is the y variable, then you know for a fact it's got to be a horizontal line. Okay, it's going to be pretty simple to graph. Not too bad. Looking at that inequality symbol, it's a less than, so we know it's going to be a dashed line. So let's set this up. Okay. Well, negative 2/3, that's my y-intercept technically, so it's kind of sitting right down in there. I want a dashed line, and I wanted just a dashed horizontal line specifically, so it's kind of cutting right through there. All right, now let's go back and read this. I want the y values that are less than this line that I created. The y value is smaller than the line. Well, if here's my line, the y value is smaller, obviously going more into the negatives. So I want to make sure I'm shading below this. Here, I'll make it obvious, just like that. Okay, and there's my answer. And again, if you wanted to just check your answer, choose a test point to plug it in. Just pick any y value that's less than this. Like, let's say down here is a -3. So if I pick y equals to be a -3, let's plug it in, is 3 times -3 plus 2 less than 0. Well, -9 plus 2 is -7. It's less than 0, so there we go. Okay. And notice I just picked a y value because there's no x to plug in, so I just picked any y value that was below that line.